dear students, a warm welcome to all of you. In this session, we will be learning the concept, Introduction to Trigonometry. Welcome to the session. So these are the key concepts that we will be dealing with in this chapter. Let's have a look. Trigonometric ratios, relation between various ratios, trigonometric ratios of specific angles, ratios of complementary angles, trigonometric identities. Now, before we get to the main topic, trigonometry is a whole new concept for you, right? Let me give you an introduction. Trigonometry is a subtopic that comes under the branch called geometry in mathematics. And trigonometry, so like the word suggests, it deals with triangles. I hope that's clear, that's all that you need. So let's begin with the chapter. The first is trigonometric ratios. Now the first trigonometric ratio, we are just familiarizing the names. So the first trigonometric ratio is sine, and on the other side, on the right side of the screen, you can see SIN written. That is how we denote sine. Even if it's spelled SIN, it should be pronounced sin. The actual pronunciation here is sine itself. So first one is sine, second one is cosine, depicted or denoted using cos, or we only say cos. Now the third one is called tangent or tan. Fourth one is called cotangent or cot. Fifth is secant or sec, and the last is cosecant or cosec. Enough with the names. Let's have a look at the definitions of all these 6 ratios. For that, consider a right triangle ABC, right angled at B, as shown on the screen. Now, all the 6 ratios can be said in terms of, or can be defined in terms of any of the other vertices A or C. And another important thing, all the 6 ratios, trigonometric ratios, are defined with respect to a right triangle, or in terms of a right triangle. So let's begin with sine C. We are taking the vertex C. We can also take the vertex A. Now let's see what they really mean. So let's take sine of an angle. Sine is the ratio of the side that is lying opposite to the angle and the hypotenuse. So sine of an angle is equal to opposite side by hypotenuse. So when we say sine C, with respect to this figure, we can say sine C is equal to AB by AC. You can see from the figure, AB is the side lying opposite to C and AC is the hypotenuse. Moving on to cos C. Cos of any angle in a triangle is the ratio of adjacent side to hypotenuse. That means the side that is lying very next to the angle. So in case of the triangle here, cos C is equal to adjacent side by hypotenuse, and the adjacent is BC. So BC by AC is cos C. Moving on to the third one, tan C, or tangent, as you might remember that. So tan of an angle is simply the ratio of opposite side by adjacent side, no hypotenuse. Opposite by adjacent gives you tan. So tan C that's why written as AB by BC. I hope you understand this. Moving on to the fourth one, cot C. Cot or cotangent is the ratio of adjacent side to the opposite side. So you can see it's BC by AB is here as cot C. Moving on to the next one, sec C or secant C. That is the ratio, sec is the ratio of hypotenuse and the adjacent side. So in this figure, sec C is equal to AC by BC. Now the last one is cosec of an angle. Cosec of an angle is the ratio of hypotenuse and the opposite side. So cosec C in this figure is AC by AB. Moving on, we have 6 ratios here, and most of them are related to other ones. So let's see what are the relation between, or how can we express the ratios in terms of other ratios. Not all ratios can be expressed in terms of others. So those ratios that cannot be expressed in other terms are sine and cos. Only sine and cos cannot be expressed in terms of any others. So they can be called as the basic trigonometric ratios. Just the naming, okay? Basic trigonometric ratios. And the remaining 4 can be expressed in terms of either sine or cos or both. So let's have a look how. Now, cosec C. Let's move back to let's revise the concept, the definition of cosec. Cosec is the ratio of hypotenuse by opposite. And what is sine? Sine is opposite by hypotenuse. Cosec is hypotenuse by opposite. Sine is opposite by hypotenuse. We can see a reciprocal relation between them. So cosec of an angle, or C in this triangle, can be written as 1 by sine C. Cosec is a reciprocal of sine, and vice versa. So sine is equal to 1 by cosec, or sine C in this case is equal to 1 by cosec C. Now the second set of pairs is sec and cos. Again, cos is the ratio of adjacent side to the hypotenuse, whereas sec is the ratio of hypotenuse and the adjacent side. So we can write sec as 1 by cos. Sec theta or sec A will come with the name of the angle will come, but in general sec is equal to 1 by cos, and the converse. Cos is equal to 1 by sec. Now moving on to tan. We already said that tan doesn't have any hypotenuse in the ratio. So tan can be expressed as sine by cos. Tan C is equal to sine C by cos C. That is a relation between tan, sine and cos. Now cot on the other hand can be written as cos by sine. Tan is equal to sine by cos. Cot is equal to cos by sine. Now you can see tan and cot are having a reciprocal relationship. So cot can be again represented or written as 1 by tan. So cot is equal to 1 by tan, and tan is equal to 1 by cot. Now you have to study or by heart the trigonometric ratios of certain specific angles. They are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now for simplicity of learning, it would be better if we group them and study them with respect to another. Like you can see on the table here, we are written 0 degree and 90 degree. We are comparing the trigonometric ratios. We are studying the trigonometric ratios of 0 degree and 90 degree by comparing them. So let's begin. Now there are 6 columns that represents each ratio: sine, cos, tan, cosec, sec and cot. Now there are 2 rows, 0 and 90. Now let's begin with sine. You can see sine 0 is 0. Sine of 0 degree is equal to 0. And sine of 90 degree is 1. You may have a look at the screen. Sine of 0 degree is 0 and sine of 90 degree is 1. Moving on to cos. What do you see? Cos 0 is 1 and cos 90 is equal to 0. I'll repeat, cos 0 is equal to 1 and cos 90 is equal to 0. They have like exchanged the values when it comes to 0, when it comes to cos, right? So similarly, let's move on to tan. Now recollect, so sine and cos are standard or basic ratios. Now tan can be expressed as sine by cos, right? So moving on to tan 0. Sine 0 by cos 0 is how we get tan 0. So what is sine 0? 0. What is cos 0? 1. So 0 by 1. When 0 comes in the numerator for any fraction, the whole answer is 0. Equivalent answer is 0. That's how we got tan 0 as 0 here. Now talking about tan 90. Tan 90 is obtained by taking the ratio sine 90 by cos 90. What is sine 90? 1. What is cos 90? 0. 1 by 0. It's actually when 0 comes in the denominator, the answer is infinity, but we are using it as not defined. So we can say tan 90 is not defined. Now moving on to cosec. Cosec, what is the relation between cosec and one of the basic ratio? Cosec is equal to 1 by sine. So for cosec 0, that is equal to 1 by sine 0. And what is sine 0? 0. So 1 by 0 is, I told you, it's infinity, but we are saying, we are calling it not defined. So cosec 0 is not defined again. Now moving on to cosec 90, that is sine 1 by sine 90. What is sine 90? 1. So 1 by 1 will give you 1. That's how cosec 90 is 1. Similarly, sec of 0 can be written as 1 by cos 0. So 1 by cos 0 is 1 by 1. So sec is equal to 1. Now sec 90 is equal to 1 by cos 90. What is cos 90? 0. So 1 by 0 is equal to infinity, not defined. Now let's move to cot. Cot can either be written as cos by sine or 1 by tan. So we will be using 1 by tan now. Alright. So cot 0 is equal to 1 by tan 0. So 1 by, what is tan 0? 0. 1 by 0, not defined. Moving on to cot 90. Cot 90 is 1 by tan 90. Now that means it's 1 by infinity. 1 by infinity will give you 0 again. So 1 by 0 is infinity, 1 by infinity is 0. So that's how we got 0 for cot 90. So 0 and 90 degree part is done. Now we'll move to 30 and 60 degree. For that, consider an equilateral triangle and let the sides of the equilateral triangle be 2 units, 2 centimeter, meter, whatever. So now we are going to construct a height on one of the sides. So in an equilateral triangle, the height will also act as the median. That is a property of equilateral and isosceles triangle. We'll take the equilateral triangle. So height will act as the angle as well as the side bisector. So we can see that height that we drew just now will be bisecting the base from 2 units into 1 separate units, or 2 separate units of 1 each. I hope you understood the concept. Alright, now what is the angle of an equilateral triangle? 60 degree. So angle of an equilateral triangle is 60 degree. So let's take the leftmost angle as 60 degree, and we know that the altitude will also bisect the angle in an equilateral triangle. So the whole 60 degree is being made or divided into 2 equal halves, 30 degree. We are considering the left triangle, or it is a right triangle. So we'll take the right triangle on the left side. Now it's a right triangle, so we have to find the length of the height. We can use Pythagoras theorem. So applying Pythagoras theorem, hypotenuse is here 2, base is here 1. We have to find height. Applying Pythagoras theorem, we will get the value of height as √3. So we have got all the sides of the right triangle on the left side. From this, we can simply list out the various ratios for 60 and 30. Let's begin with 60 degree. Sine 60. Sine is equal to opposite by hypotenuse, that is √3 by 2. Now cos 60 is equal to 1 by 2. Tan 60 is equal to opposite by adjacent, that is √3 by 1 or √3. Moving on to 30 degree, sine 30 is opposite by hypotenuse, that is 1 by 2. Cos 30 is equal to adjacent by hypotenuse, that is √3 by 2. Tan 30 is equal to 1 by √3. I hope you understood. Now if you observe the ratios of 60 and 30 look like those of 90 and 0. You can see sine 60 and cos 30 are the same value. Again, cos 60 and sine 30 are the same value. So there is a relation, and we can observe that tan 60 is 1 by root 3, root 3, and tan 30 is 1 by root 3. Those are reciprocals of each other. So if you study or learn one of the ratios of one of the angles, it would be easier for you to predict the ratios of the other angle. That's a tip. Okay. Now, once you know all these three, sine, cos and tan, it would be easy for you to sort out the remaining sec, cosec and cot. That's why we haven't shown it here. Now, moving on to 45 degree, that will be done alone. For this one, we have to consider a right isosceles triangle, right-angled isosceles triangle. In a right-angled isosceles triangle, the two arms of the 90-degree angle will be 0. Why? Because it's an isosceles triangle. So let the equal sides be 1 unit each. Now we also know that in an isosceles triangle, the base angles are the same. So angles on either side of the hypotenuse will be equal. Now applying the angle sum property of a triangle, we can find that those angles are 45 degree each. And using Pythagoras theorem, we can find the length of hypotenuse as root 2. So we have got 1, root 2 and 1. Now we can take any one vertex because both are 45. So you can take any one vertex and list down the ratios for 45 degree. So sine 45 is 1 by root 2. Cos 45 is 1 by root 2. And tan 45 is 1. So that's easy to write, revise or learn, right? So sine 45 and cos 45 are equal and tan 45 is 1. Now let's discuss the concept of complementary ratios or ratios of complementary angles. What do you mean by complementary angles? If two angles add up to 90 degree, we can say that one angle is a complementary of the other one. So remember when we studied the names of the ratios, for sine and it was cosine, for tan it was cotan, and for the sec it was cosecant, secant it was cosecant, So the name of those angles come from the concept of complementary angles. Cosine is the complementary sine and cotan or cot is the complementary tangent and cosec is the complementary secant. So with that we can get the complementary, we can understand that complementary ratio of sine is cos, complementary ratio of tan is cot and complementary ratio of sec is cosec. Now let's see, sine 90 minus theta is equal to cos theta. Now theta is a Greek alphabet, so indicating angle. So sine 90 minus theta is equal to cos theta. Let's have a look at that. Now we can say angles 50 degree and 40 degree. 50 plus 40 will give you 90. So we can say that 50 and 40 degree are complementary of each other. So when we say sine 90 minus 50, we can replace that with cos 50. So sine 90 minus 50 is equal to cos 50. We will use that in the numericals. Moving on, similarly the converse is also valid. Cos 90 minus theta is equal to sine theta. Now tan 90 minus theta is equal to cot theta. Cot 90 minus theta is equal to tan theta. Sec 90 minus theta is equal to cosec theta and cosec 90 minus theta is equal to sec theta. Here comes the topic trigonometric identities. Now you are all familiar with algebraic identities, different identities. Now similarly trigonometry also follows a list of identities. Now we shall study 3 of them. Have a look at the screen. Sine square plus cos square is equal to 1. Tan square plus 1 is equal to sec square. Cot square plus 1 is equal to cosec square. Now A is any angle, you can replace it with any variable or any degree. You can say sine square 55 degree plus cos square 55 degree is equal to 1. And tan square 30 plus 1 is equal to sec square 30. Then cot square 2 plus 1 is equal to cosec square 2. Anyhow. So all you have to do is study the relation between sine square or these identities. Now we shall start doing the numericals. The first one is very short answer type questions carrying 1 mark each. The first question, if theta is equal to 45 degree, then what is the value of 2 sec square theta plus 3 cosec square theta? So the question, theta, the value of the angle has been given and we are supposed to calculate and evaluate the given equation. 2 sec square theta plus 3 cosec square theta. Now theta is 45, you have to find sec theta and cosec theta. What is sec 45 and what is cosec 45? We know that sine 45 is 1 by root 2, so cosec 45 will be reciprocal of it, that will be root 2. Similarly, sec theta is equal to 1 by cos, so again reciprocate it, so 1 by cos 45 will be root 2 again. So putting the values and calculating, we got the final value as 10. Moving on to the next question, the second question. If root 3 sine theta is equal to cos theta, find the value of 3 cos square theta plus 2 cos theta, the whole divided by 3 cos theta plus 2. Now in the given question, we have sine theta on one side and cos theta on the other side. So you might have to isolate the numbers on one side and the ratios to the other one. For that, transpose sine theta to the other side. So the equation will become root 3 is equal to cos theta divided by sine theta. What is cos by sine? It's cot theta. Now we get cot theta is equal to root 3. You can check the measurements or the ratios of specific angles and see cot theta is equal to root 3 is for which angle. So we will get it as 30 degree. We will get theta as 30 degree. If you have trouble remembering the angles, you can also convert cot theta into tan theta. So we can write tan theta, take reciprocals on either sides. So cot theta is equal to root 3. After being reciprocated, we will get tan theta is equal to 1 by root 3. Now tan of which angle is 1 by root 3? 30 degree. So theta is equal to 30 degree. Let's keep it over there. Now we have to evaluate 3 cos square theta plus 2 cos theta divided by 3 cos theta plus 2. When we get such an equation, try simplifying it and cancelling out the common terms. Make it as simple as possible, then put the corresponding values. So we shall try simplifying it. We can see in the numerator cos theta is common. So you may take it out. So the equation will become cos theta bracket open 3 cos theta plus 2 bracket close. Now the denominator will remain the same. Now you can see 3 cos theta plus 2 is present in both the numerator and the denominator, and it is being multiplied in the numerator. So you can easily cancel those. Now what's remaining? Cos theta. And we already got theta is equal to 30 degree. So we can simply put the value 30 degree and find cos 30. That is equal to root 3 by 2. Moving on to the next question. Evaluate sine square 19 degree plus sine square 71 degree. Now remember the ratios of specific angles. Did we study sine or cos or tan of 19 or 71? No. So whenever angles other than 0, 45, 30, 60 and 90 degree come, we have to apply complementary ratio concept. So sine square 19 plus sine square 71. We have to first check if the given angles are complementary. How do we check? If they sum up to 90 degrees. So when we add 19 and 71, we will get 90 degrees. So they are complementary. Now the next process that we have to do is express any one of the angles in terms of 90 minus the other one. pick any angle. So in this case, we are picking angles 71 degree, and we are going to express or replace 71 in terms of 19. How can we write 71? 90 minus 19. 90 minus 19. So the equation will be rewritten as sine square 19 plus sine square 90 minus 19. Now what is sine 90 minus 19 or sine 90 minus theta? Cos theta. Sine, cosine, complementary sign. So sine square 19 plus the sine square 90 minus 19 can be written as cos square 19. I hope that step is clear. Now that the obtained equation is of the form sine square a plus cos square a. So we have to apply the identity. What is sine square a plus cos square a? 1. So the answer is 1. So evaluate the answer for that question is 1. Now the next question. If triangle ABC is right angled at B, what is the value of sine A plus C? So there is a triangle, a right angled at B. We have to find sine A plus C. Now another important thing that you have to make sure is that sine A plus C, when we write it like that, we can't multiply sine A and we can't split the bracket like sine A plus sine C. It's not like we are multiplying sine to the angles. So sine A plus B should be sine A plus C itself. No opening the bracket and multiplying or applying it to both. So we are supposed to find sine A plus C. Let's see how. So we have to start with angle sum property. Angle sum of a triangle is 180 degree. So angle A plus angle B plus angle C is equal to 180 degree. Now substituting for angle B as 90 and taking it to the other side, we will get angle A plus angle C is equal to 180 minus 90 is equal to 90 degree. So A plus C is 90. Now the question is to find sine A plus C. So sine A plus C is equal to sine 90, that is 1. Moving on to the next question. If cos A plus B is equal to 0 and sine A minus B is equal to 1 by 2, then find the value of A and B, where A and B are acute angles. Now the condition that A and B are acute angles is only to make sure that the value that we get are lower than 90, that's it. So we don't have to use that condition. So the two equations are given. Cos A plus B is equal to 0 and sine A minus B is equal to 1 by 2. Now cos of which angle is 0? We have to check that, and cos 90 is equal to 0. So we can simply equate A plus B is equal to 90. Similarly, sine of which angle is 1 by 2? And we will get sine 30 is equal to 1 by 2. Therefore, A minus B is equal to 1 by 2. So A minus B is equal to 30. So A plus B is 90. A minus B is equal to 30. So we have moved to linear equations in two variables. Solve them using any method and we will get angle B is equal to 30 degree and angle A is equal to 60 degree. Moving on to the next question. Short answer type questions of 2 marks each. If x is equal to P sec A plus Q tan A and y is equal to P tan A plus Q sec A, then prove that x square minus y square is equal to P square minus Q square. Now please note this question. This is a very important and frequently asked question. Now we shall begin with x square minus y square because we are directly given x is equal to something and y is equal to something. So x square minus y square will be equal to x is equal to P sec theta plus Q tan theta. So x square will be P sec theta plus Q tan theta the whole square. Always remember whole square, not individual square. Now similarly, y square will be equal to P tan theta plus Q sec theta the whole square. Now another usual mistake that students make is simply put the square and open the bracket. No, these are in the form a square plus b square. So you have to apply the identity a square plus 2ab plus b square. So there will be 3 terms when we apply the identity before opening the brackets. After opening the brackets and taking out and cancelling out the common terms, we can prove that x square minus y square is equal to p square minus q square. Here comes the next question. Prove the following identity. Cos cube theta plus sin cube theta whole divided by cos theta plus sin theta is equal to 1 minus sin theta into cos theta. So we will start with the LHS. Cos cube theta plus sin cube theta whole divided by cos theta plus sin theta. Now you may have to apply the algebraic identity here. You may take down a cube plus b cube is equal to a plus b into a square plus b square minus ab. So you may need that to apply it here. So cos cube theta plus sin cube theta is in the form a cube plus b cube. So you have to expand it using the identity that is equal to a plus b into a square plus b square minus ab. So the numerator will become sin theta plus cos theta into sin square theta plus cos square theta minus sin theta cos theta by sin theta plus cos theta. Denominator is unchanged. Again, we can see that sin theta plus cos theta is common in both numerator and denominator. And one more thing, those sin theta plus cos theta is being multiplied in the numerator. So you can simply cancel out them. If sin theta plus cos theta was being added or subtracted, you won't be able to cancel it. That's a point you can note. Now the equation will become sin square theta plus cos square theta minus sin theta cos theta. By identity, trigonometric identity, sin square theta plus cos square theta is equal to 1. So the equation is 1 minus sin theta cos theta. That is the RHS, hence proved. Now the next question. Simplify 1 plus tan square theta by 1 plus cot square theta. Now there are 2 ways to do this. We have used only one method here. You can either apply the identity directly, like 1 plus tan square theta is sec square theta and 1 plus cot square theta is cosec square theta, then cancel out. But we are going to use a different method. We know that whenever only sine and cos are the basic ratios. So whenever ratios other than sine and cos have come and the question is to simplify or prove or evaluate some equations, you have to replace the other ratios with sine, cos or both. Like as in this question, 1 plus tan square theta can be written as sine square theta by cos square theta. So tan theta is sine by cos, tan square will be sine square by cos square. Similarly, cot theta can be written as cos square theta by sine square theta. Cross multiplying and evaluating, we will get the final answer as tan square theta. Moving on to the next question. If cos x is equal to cos 40 into sin 50 plus sin 40 into cos 50, find the value of x. The x value is what we have to find. So in this question, 40 and 50 are not the angles that we already learned, whose ratios we already discussed. So they come under complementary ratio concept. Now we know that 40 plus 50 is 90, and we already discussed that whenever complementary ratios concept is to be applied, we have to replace one of the angles in terms of the other one. Let's see how. So cos x is equal to cos 40 sin 50 plus sin 40 cos 50 is the question. Now there are 2 terms. Cos 40 sin 50 is one term and sin 40 cos 50 is the other term. In both the terms, we can replace 50 with 90 minus 40. You can also decide which one you have to replace. So here we have decided to replace 50. You can also replace 40. It's your wish. Here we have written 50 as 90 minus 40. So the equation will become cos 40 sine 90 minus 40 plus sine 40 cos 90 minus 40. Now what is cos or sine 90 minus theta? Cos theta. What is cos 90 minus theta? Sine theta. So the equation will be cos square 40 plus sine square 40. What is cos square 40 plus sine square 40? That is 1. Now cos of some angle is equal to 1 and cos of which angle is 1? 0. Therefore the value of x is equal to 0 degree. Moving on, evaluate sine 50 plus theta minus cos 40 minus theta whole divided by sine 40 into cosec 40 plus tan 1, tan 40, tan 50, tan 89 whole divided by 4 into cos square 29 plus cos square 61. A long question, right? So again cos there is 40, 50, then 61, 29 and 189 coming. So we have to apply complementary ratio concept. So we have to replace one of the angles with 90 minus the other, and upon substituting and cancelling the common terms, we can reduce the equation to evaluate the equation to 0 plus 1 by 4, or equivalently 1 by 4 will be the answer. Moving on to the next type, long answer type questions carrying 3 marks each. In figure, triangle PQR, right angled at Q, PQ is equal to 6 cm and PR is equal to 12 cm. Determine angle QPR and angle PRQ. So first of all, we are going to find the other side QR using Pythagoras theorem. So PQ square plus QR square is equal to PR square. Upon substituting and finding out, we obtained QR as 6 root 3 centimeter as shown on the screen. Now we are supposed to find angle QPR and angle PRQ. We can apply tan of angle R or angle PRQ is equal to PQ by QR. We will get it as 1 by root 3. So tan some angle is equal to 1 by root 3 and tan of 30 is 1 by root 3. Therefore angle R is equal to 30 degree. So angle PRQ is equal to 30 degree. Similarly, tan P can be equated to QR by PQ, and upon cancelling we will get angle QPR as 60 degree. Here comes the next question. Find the value of tan 20 by cosec 70 the whole square plus cot 20 by sec 70 the whole square plus 2 tan 75, tan 45, tan 15. Now when we write ratios together without any dots, they simply mean multiplication. So tan 75, tan 45, tan 15 means that they are being multiplied. Okay, so again 20, 70 they are complementary. Now 75, 15 are complementary. So replacing one of these. Now in this one, tan 20 by cosec 70, the complementary angles are coming above and below, but that's okay, we can replace one of them. So we have decided to replace the numerator, the 20 in the numerator. So instead of writing tan 20, we are writing tan 90 minus 70. Similarly, in the next term, cot 20 is being replaced by cot 90 minus 70. Now in the next one, tan 75 is being replaced by tan 90 minus 15. And again, in these type of big questions with complementary angles, we can simply cancel out them and we will get the final answer as 3. Next question. Prove that sine theta minus cos theta divided by sine theta plus cos theta plus sine theta plus cos theta divided by sine theta minus cos theta is equal to 2 by 2 sine square theta minus 1. That's too long, and the question is a very frequently asked, not the specific question, prove that type of questions are very frequently asked. At least 3 questions will be asked in one question paper. So it takes practice to familiarize with solving this. You won't be able to solve it at first. You have to do at least 20 questions in this type, as in prove that type questions in trigonometry. So make sure you get enough practice. So let's move on. So sine and cos are the basic ratios, so we don't needn't convert them into other ratios, so we can simply use them in the basic forms itself. So the only process that we can do here is adding together on the LHS, as in they are different denominators, so we can cross multiply them and add and multiply the denominators in the middle. So we will get sine theta minus cos theta into sine theta minus cos theta plus sine theta plus cos theta into sine theta plus cos theta, the whole divided by sine theta plus cos theta into sine theta minus cos theta. Now sine theta minus cos theta is being repeatedly multiplied twice. So that is sine theta minus cos theta the whole square. Similarly, sine theta plus cos theta is being multiplied twice, so that becomes sine theta plus cos theta the whole square, divided by sine theta plus cos theta into sine theta minus cos theta is of the form a plus b into a minus b, that is a square minus b square. So we can simply write sine square theta minus cos square theta, and in the above both of those other form, a minus b whole square and a plus b whole square, we have to apply the identities and open the brackets, and the 2 sine theta cos theta will be cancelled, and in the end we can prove the numerator as 2 and the denominator will be 2 sine square theta minus 1. Moving on to the next question. If tan theta is equal to a by b, prove that a sine theta minus b cos theta by a sine theta plus b cos theta is equal to a square minus b square divided by a square plus b square. Now again, a sine theta minus b cos theta, they are in the simple basic format. So all we can do is divide both the numerators and denominators with cos theta, so as to cancel at least one of them. So the equation will be a sine by cos plus minus b cos by cos divided by a sine by cos plus b cos by cos. So the equation will be a tan minus b by a tan plus b. Now we are given that tan theta is equal to a by b. Now simply substitute and prove that the LHS is equal to RHS. Now the next question, prove the identity sec theta minus cos theta sec a minus cos a bracket into cot a plus tan a is equal to tan a sec a. So I had already specified that when the ratios other than the basic ratios come, you replace them. So sec, cot and tan can be replaced and written in terms of either sine or cos or both. So the equation will be 1 by cos a minus cos a into cos a by sine a plus sine a by cos a. You operate each bracket separately and combine them, and we will be able to prove that the LHS is equal to tan a into sec a, that is the RHS. Now we shall move on to very long answer type questions of 4 or 5 marks. If sec theta plus tan theta is equal to p, prove that sine theta is equal to p square minus 1 divided by p square plus 1. They had directly given the equation for p, that is equal to sec theta plus tan theta. So all you have to do is begin from the right hand side, p square minus 1 by p square plus 1, and put the value of p as sec theta plus tan theta. So p is sec theta plus tan theta, then p square will be sec theta plus tan theta the whole square, not sec square theta plus tan square theta. So whole square, so a plus b whole square will be a square plus b square plus 2ab, and opening the brackets and applying the cancellation techniques, we will get it as sine theta by cos theta divided by 1 by cos theta, or tan theta by sec theta, that will be equal to sine theta. Moving on to the next question. Evaluate 4 by cot square 30 plus 1 by sine square 60 minus cos square 45. Now that's easy. all you have to do is substitute the values of cos 30, sine 60 and cos 45, square them. So putting on the values, we can simplify them and get the evaluate or the value, final value as 13/6. Moving on to the next question. If theta is equal to 30 degree, verify the following. The first part, cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Now the second part of the question, sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So all you have to do is put theta is equal to 30 in both LHS and RHS and verify that they are equal. So in LHS of the first part, cos 3 theta will be cos 3 into 30, that will be cos 90, that is equal to 0. Now 4 cos cube 30 minus 3 cos 30, that will be the RHS, and upon putting the values, we will get 0 as a value or the final value. Therefore LHS is equal to RHS. And the second part is also done that way. I want you to try that by yourself. All you have to do is put the value of theta as 30. Here comes the next question. Prove that b square x square minus a square y square is equal to a square b square if x is equal to a sec theta, y is equal to b tan theta. That's the first part. And the second part is x is equal to a cosec theta, y is equal to b cot theta. So there are two parts for this question. Taking the value of x as a sec theta and y as b tan theta, we may begin from the LHS and we will be getting b square into x square will be a sec theta the whole square minus a square into b tan theta the whole square. Opening the bracket, it will be applying the square. The equation will become b square a square sec square theta minus a square b square tan square theta. We can see a square b square is common in both the terms, so we can take it out. The remaining will be sec square theta minus tan square theta. Now we may have to recollect the second identity, the second trigonometric identity, 1 plus tan square theta is equal to sec square theta, or sec square theta minus tan square theta is equal to 1. So you may apply that here and we will get a square b square, hence proved. Similarly, put the value of x as a cosec theta and y as b tan theta, b cot theta, and substitute it in the LHS. We can do the same thing and we will be getting a square b square into cosec square theta minus cot square theta. Again, as per the identity, 1 plus cot square theta is equal to cosec square theta, or cosec square theta minus cot square theta is 1. So we are left with a square b square, hence proved. Moving on to the next question. This is another frequently asked type question. Root of ck minus 1 by ck plus 1 plus root of ck plus 1 by ck minus 1 is equal to 2 cosec A. So there is a general format to do such type of question, the one with roots coming. We have to multiply both individual roots with the conjugates of the denominator. Conjugate means the sign shifted version of the denominator with the root itself. So on multiplying that way, we can reduce or cancel the roots and we can reduce the equation and prove that the LHS is equal to 2 by sine theta. So that, or it is equal to 2 cosec theta, cosec A, sorry. So LHS is equal to RHS can be proved easily. Or you can also replace sec theta in the form of 1 by sine in the end. But I don't suggest that doing in the beginning, because whenever root, the numerator by denominator comes, the best way possible to solve such questions is to multiply both numerator and denominator with root and conjugate of the denominator. I hope that's clear. That's it. Thank you.